Hello, good morning. Diego Redondo speaking. This is, thank you, all of you, to join this dissemination event about RETROFEED project. Today we are going to talk about the energy audit in times of COVID-19, focusing in the augmented reality experience that we are doing RETROFEED project. So we are going to wait a couple of minutes more to all the attendees can join the meeting, and we start in 1 or 2 minutes. Okay, hello, good morning to all. Thank you to join this dissemination event. So my name is Diego Redondo. I'm the project coordinator and the project manager of the RETROFEED project. And we are going to start with this dissemination event related with the energy audits in time of COVID. That is a key aspect of the RETROFEED project right now. So now we are going to make a brief welcome and retrofeed overview of the project. So today we are going to have also an overview and outlook of the European Commission from our project officer, Lucia Fernandez. She is going to present the S.p.A program, also the Green Deal, and all the aspects related with the with this her unit. And then we are going to continue with the energy audits and augmented reality. That is the core of this presentation of this dissemination event. And in this case, RINA is going to present this technology that we are using in the RETROFEED project. Then we are going to have a panel discussion or a roundtable to talk with the end users that are the key of the project, because they are where the end user, where we are going to implement of the solution of the RETROFEED project, and also where we are doing the energy audits. And then finally, we are going to also present the REVAMP project. The project coordinator of this project is going to explain us this project that is also very related with the RETROFEED project, because it's focusing in the aluminium sector. And then, of course, finally, we will have a round of question and answer if you have any doubt, and also a brief conclusion of the events. So if you have any question during the meeting, we will have a brief time at the end of the event to answer you. So please use the question and answer options that you have in the Teams. In the top of your screen, you have this option to send us the questions. And also, we have to say that this event is going to be recorded. So then it will be uploaded in our website, and also we are going to share all this record in our social media channels and and so we will send you the record of the event after the event. So as I have said, I'm Diego Redondo. I'm the project coordinator working at CIRCE. That is a research center that is focusing in the energy aspects and also energy audits and related with renewable energy and so on. And also today with me is Ana González, that so the technical project coordinator of the project. She's the expert in all the technical issues for the retrofeed project. So this is what is going to present, but well, remember the most important, the retrofeed project is, the name is the implementation of a smart retrofitting framework in the process industry towards its operation with variable, bio-based and circular feedstock. So we are going to make some retrofit actions, but take into account the circular, variable and bio-based feedstock. So yeah, we have two very important things, is that this project have a funding of about 10 million euros, but about 5.5 million is going to be investment by the end users and other project partners. So this is very important because we think that all these partners are believe in the results of this retrofit project, and they are going to invest some money for that. So the project coordinator, we are at CIRCE, that are in Spain. And I'm going to present more or less very briefly also all the partners of the project. So we have the end user that are the key of the project. We have in Spain TORRECID, that is in the ceramic sector, and also in Spain we have FERTIBERIA, that is focused in the agrochemical sector. Then we have CECIL in Portugal, that is in the cement sector. Then we have Pitini, that is in place in Italy and is focused in the ferric sector. Also the Tenari SILCOTUB, that is in Romania. And finally, but not the last, ASAŞ, that is in Turkey, that is in the aluminium sector. So this is our end users, the most important partners in the project, because we are going to implement all our solutions. For help them, we are the RTD performance that are helping them with all the data from this, to take the data, to provide, to coordinate also the modeling of the demo sites and so on. We are CIRCE, and also IMEN from Spain, that also are helping us in the CECIL demo site. CIRCE is working in the CECIL, FERTIBERIA and TORRECID demo sites. Then EM from Poland, that is working in ASAŞ demo site, but also helping in the design of burners in CECIL. And finally, CCM from RINA in Italy, that is working with Feno and SILCOTUB. We have also some engineering and technology providers that are make the developments of the manufacturing of retrofit solutions. For example, AUDIT is in charge of development of the DSL's tool, that is the tool that is going to manage all the solution of the retrofit. Also audits, that is management the communication protocols for the DSAs. S.p.A from Turkey, that is developing the novel oxygen injector in ASAŞ. And finally, HTT from Czech Republic, that is also designing the novel injector and burners in ASAŞ. And the horizontal partners that help in all the retrofit project, We have IBL from Sweden that it's evaluating the environmental and socio-economic impacts of the solutions. Also, it's going to coordinate the trainings of the solutions. Then we have RINA that is in charge of the energy audits, but then is going to present us this the solution of the Kyber helmet that we are using in these energy audits. And then we have Geo that it's the leader of the exploitation and business plan of the project. And finally, the energy EEAP, energy efficiency in industrial processes, that are the leader of the dissemination event, and this event has been prepared with the support of EEAP. So thank you so much for your support in this event, and also is working in some of the activities related with the development of the retrofit methodology. So now I'm going to pass the floor to Anna, that is going to explain better all the technical aspects of the retrofit project. So Anna.
Hello everybody, thanks Diego. And my name is Ana Gonzalez. I'm the project coordinator, and I'm going to give you the technical overall of the project. So the main project of retrofit is to enable the use of an increasingly variable bio-based and circular feedstock in process industries through the retrofitting of the core equipment and the implementation of an advanced monitoring and control system, and providing support to the plant operator by means of decision support system covering the production chain. As Diego presented, we are going to demonstrate all the solutions in 5 resource and energy intensive industries: in the ceramic, cement, aluminium, steel, and agrochemical sector. Next, please. And the overall concept of the project is focused on the retrofitting of the core equipment of the process to be adapted to the variable feedstock. These ad hoc solutions will require the development of a monitoring and control system within the project for optimizing the performance of the retrofit solutions. The different modules will be integrated in the decision support system tool, which will allow know the best retrofitting strategy and the most adequate performance of the process. The TRL7 expected to reach of the project solutions will allow to be replicated in a short time. Next, please. Okay, I'm going to go through the technical action to be implemented in each end user. In TORRECID, which is a producer of frits and glaze for the ceramic and glass sector, the core equipment corresponds to a frit furnace, where one of the main concern is to reduce the raw material losing between the load changes. To tackle this inefficiency, and a smart combustion control will develop, adjusting the combustion condition to the frit heat requirements. In addition, the feeding system will be enhanced, and together with dedicated sensor will be integrated in the monitor and control system in order to optimize the energy resource. A redesign of the heat recovery system of the flue gases will be tested for 2 different purposes. One of them is improving the combustion air preheating process, and the second one is extending the use of the hot air to the frit drying. With these actions, is expected to achieve energy and material saving and optimize the fuel and combustion air use. A reduction of the material waste from fall to seal fall, and an improvement of the monitor and control system is expected. Next, please. In the case of Cecil, which is one of the Portugal cement producer leader, retrofit action will be centered in the core equipment. the rotary kiln. A full-scale multi-fuel burner will be designed to be used with alternative fuels. New innovative sensor will be developed and installed to monitor the combustion process based on flame images and characteristics of the clinker composition by means of optical techniques. In addition, alternative fuel will be also characterized to support the kiln performance. The implementation of these actions will lead to extend a substitution of 60 to 80% of fossil fuel, which will contribute to a reduction of the CO2 emissions. In addition, it's expected a 5% of specific energy consumption decreasing, and so on, an increment in energy efficiency. A flue gases analyzer will improve the monitor and control system. Next, please. In the case of ASAŞ, which is one of the leaders of the aluminium manufacture in Europe, pursues to increase the amount of scrap in the melting process, maintain, of course, the product standards. In this manner, a reduction of the primary aluminium billet use can be reduced. For this regard, a delacquering system will be installed to remove the coating layer as paint, oil, and so on to allow to increase the share of low-quality scrap in the feeder line. In addition, an oxygen injection system and head burner will be designed and installed to improve the combustion performance inside the furnace. Oxygen, a total organic compounds analyzer, will be installed also to support in the process management and to ensure the adequate emission level, which lead to an improved monitor and control system. The expected goals are related with increment of the share of the scrap at up 50%, will we reduce the energy consumption in 15 times. In addition, this action will generate a more efficient combustion and so a reduction of the greenhouse gas emissions. In the steel sector, please, next. Thank you. In the steel sector, we have two end users, FERRIERE and SILCOTUB. In both cases, activities are centered in the electrical arc furnace, where circular economy concept will be applied. In the case of FERRIERE, biochar and plastic grains will substitute the use of fossil fuel for combustion. At the same time, anthracite will be replaced by biochar as carbon source, so that the injection system and burner are required to be modified, whereas in SILCOTUB, rubber and plastic injection will be used as energy provider in the melting process. In addition, in both cases, a reduction of greenhouse gases are expected, as I mentioned previously, in the implementation of circular economy concept will support the reduction of feedstock. And next, please. FERTIBERIA, which is a Spanish fertilizer producer and one of the leading international providers of ammonia and its derivatives, the retrofitting activities are centered in the phosphoric reactor. The idea is to replace the importing phosphoric, designing a new reactor to incorporate bio-based waste. This modification will lead to a substitution of 10% of the currently use of phosphoric source, integrating raw material from waste and reducing cost. New sensors to monitor and control the new system will improve the monitor and control system. And with all this action, we expect, next please. Thank you. With all these actions, we expect to obtain an increase of resource and energy efficiency by 20%, a reduction of greenhouse gases generation by 30%, a reduction of fossil fuel consumption by 20%, and operational saving costs by 30%, and a meat productivity increase of 20%. Next, please. And also, we would like to emphasize, as part of one of the first tasks that we have in the project, we found complementarities between the end users and possible synergies that we think that is important to remark. For example, in terms of complementarities, the different sensors developed in CIRCE can be widely applied in other sectors. In the case of the sector of measure, the heat calorific value can be potentially employed in FERRIERE and SILCOTUB to easily accommodate the process condition to the feedstock, whereas the sensor to determine the clinker structure could be adapted to the case of the feed produced in TORRECID. The combustion diagnosis tool could be also applied in TORRECID and ASAŞ to determine the combustion performance in this case. The dust recovery opportunity arising in SILCOTUB and CIRCE could be valorized for the case of ASAŞ and TORRECID, where metal dust is formed during the smelting process. And the lacquer resistance can be an option to the apply in FERRIERE North and SILCOTUB, although further evaluation is required. And finally, the isothermic reaction expected in the fertilizer production can be evaluated as energy source in other sectors. The potential synergy that we have already found are as follows. The use of TORRECID wastewater as industrial grade lime, recover electrical arc furnace dust which contains zinc, iron, and magnesium to be used as plant fertilizer. The ASAŞ slabs contain aluminium and aluminium oxide, which can be used in TORRECID, FERRIERE North, and SILCOTUB. Next, please. The oxide from ASAŞ can be used in FERTIBERIA for the fertilizer production. The content of different valuable metal material in waste freight produced by TORRECID can be considered as raw material in the steel sector. And finally, the high content of metal oxide and aluminum produced in the steel sector can serve as feedstock in the ceramic freight process. Next, please. And next. So finally, the final remark in this project will make industry more flexible to the new producer scenario. The digital and mechanical revamping action we will carry out in 5 resource and energy intensive industry focused on the core equipment. A decision support system will integrate different models to support the decision-making process. Synergies and complementarities have been identified, and to facilitate to the European industries the transition to a more sustainable and responsible production practice, incorporating bio-based and circular economic concepts. And that's it for my side.
Okay, thank you, Anna. Thank you, Anna, for your presentation. Let's see, one moment. Okay, so now it's time to Lucia Fernandez, that is going to present us the S.p.A program. So Lucia, I think, yeah, you are here, so you can share your screen if you want.
you see my screen?
Yeah, we can see your screen, and now we can listen you perfectly.
Okay, come back to my screen. Okay. Yes. Well, I will also speak, as it is also the subject of the part of the subject of the online event today on the Commission response to COVID-19, the European Green Deal and Horizon Europe. As we are finishing H2020, I prefer to focus on what comes next instead of what's running nowadays, which is also important, but I think it's more of interest for the participants to learn about what's coming in the next framework program. So I am the project officer of RETROFEED and REVAMP, and I work in the Research and Innovation DG of the European Commission in the directorate called Prosperity in the unit Sustainable Industry Systems. So in the directorate Prosperity, we deal with sustainable solutions, technology and solutions for industry to contribute to the climate objectives, as well as the digital era, and also to make a competitive Europe with including job creation and development of skills. We also deal with subjects related to valorization and IPR management or standardization, which is not exactly the core of my unit, but of other units in the Prosperity Directorate. And I will start with a short explanation on the response of the Commission to coronavirus. The Commission is working on many fronts to contain the spread of the coronavirus, to support the health systems in the European countries, and to counter the socio-economic impact of the pandemic with unprecedented measures both at national and European level. Within those measures, there is the recovery plan, which has been approved recently by the European leaders and will lead the way out of the crisis and lay the foundations for a greener, more digital and more resilient Europe. It is the largest stimulus package ever financed through European budget, with a total of 1.8 trillion euros. Next to that, of course, the Commission is supporting research for treatment, diagnosis and vaccines. The coronavirus global response was launched at the end of last spring to ensure global access, universal access to treatments, tests and vaccines. For example, the pledging marathon in June raised 16 billion euros from donors worldwide. Also, the Commission has mobilized over 1 billion euros from H2020 and also, yes, indeed, to support the coronavirus global response, and adjusted the European state aid rules to facilitate relevant research, development and innovation. Of course, different measures have been taken in public health, borders and mobility, such as medical guidance for European countries and ensuring availability of personal protective equipment and testing across European countries, which was compromised at the beginning of the crisis and now is ensured through different measures. Also, it has set the ground towards a European health union. It has proposed the coordination and communication of different measures across the member states at the European level, which has been a problem at the beginning, or it has not been ideal at the beginning of the crisis and still can be further developed. It has also set guidelines for border management measures, which has also ensured the free movement of essential workers, etc. And what is also very important, the Commission has fought disinformation about coronavirus in the social media. We know that R&I is key against the coronavirus outbreak. So since the beginning of the crisis, different RNI actions has been done, starting also already at the end of January with the first emergency call for expression of interest with 48 million euro, which funded 18 projects on epidemiology, diagnosis, treatment, and vaccines. Other actions were taken over the year, as you see in the slide. I won't stop here, but just to show that the response has been very active in funding, but also in policy action. Many actions were taken since the beginning, since April, as for example, the ERA versus Corona Action Plan, the COVID-19 data portal, or the EU vaccines strategy in summer, as well as recently investment in preparedness and response to infectious disease outbreaks. And as you know, H2020 grant management also was tackled already in the spring with a set of frequently asked questions for H2020 projects that were published, including a 6-month extension request, the possibility of this request. Those were, as is recently published, these frequently asked questions continue to apply. I will now talk briefly about the Commission priorities. As you know, every 5 years a new Commission term is started, and with that new priorities areas are set. Those are the priority areas in which the focus will be placed during the Commission term. Indeed, our vision is to achieve a sustainable, fair and prosperous future for people and planet based on European values, tackling climate change, helping to achieve sustainable development goals, and boosting the Union's competitiveness. In that regard, and based on the Council strategy agenda, and also from the discussions with European Parliament groups, these 6 Commission priorities were set for 1924. These are the European Green Deal, a Europe fit for the digital age, an economy that works for people, a stronger Europe in the world, promoting our European way of life, and a new push for European democracy. The first 3 are also focus is where we focus also in our directorate through RNI actions, and the first 2 are brought together in the new industrial strategy for Europe, which refers to the twin transition for a green and digital industrial transformation. I will give a short explanation now on the European Green Deal, striving to be the first climate-neutral continent. At the end of last year, the European Green Deal was published with a set of aspects where Europe would focus in order to transform the European economy for a sustainable future. Climate change and environmental degradation are a threat to Europe and the world. And to overcome these challenges, Europe needs a new growth strategy where there are no net emissions of greenhouse gases by 2050. The economic growth is decoupled from resource use, and no person and no place is left behind. The European Green Deal provides an action plan to boost the efficient use of resources by moving to a clean, circular economy, to restore biodiversity and cut pollution. Indeed, we can make Europe's economy sustainable if we turn climate and environmental challenges into opportunities, and we make the transition just and inclusive for all. Some of the actions already taken over this year are the European Climate Target Plan for 2030. So we have identified that we need to set a more ambitious path for the next 10 years. That in that line, the European Commission has proposed to cut net greenhouse gas emissions by at least 55% by 2030. This compared to the 90s levels. That would increase our current target from 40% to 55%. Next to that, the European Green Deal investment plan will mobilize at least €1 trillion of investments over the course of 10 years. And there will be a strong link between Horizon Europe and the European Green Deal. Horizon Europe plays a pivotal role in shaping, supporting and delivering on European policy priorities and, of course, the European Green Deal, with more than 35% of the expenditure from actions under the Horizon Europe program that will contribute to climate objectives. I will now give a short introduction on the Horizon Europe, which is the next European Research and Innovation Investment Program for 2021-2027. We know that while Europe benefits from world-class research and strong industries, we can do better at transforming this into leadership in innovation and entrepreneurship. We account for 7% of the world's population, but we have 20% of global R&D and 1/3 of all high-quality scientific publications. But we're lagging behind on European business R&D investment if we compare ourselves to other regions in the world. But we know that R&I investments are key for a sustainable and inclusive recovery. R&I boosts the EU's productivity, jobs, and global competitiveness. For example, 2/3 of European productivity growth over the last decades has been driven by R&I investments. We also know that R&I accelerates the digital and ecological transformation of our societies. For that reason, the Commission has set an ambitious European Research and Innovation Framework Program for 2021-2027, Horizon Europe, to strengthen Europe's scientific and technological basis and the European research area, to boost Europe's innovation capacity and competitiveness and jobs, to deliver on citizens' priorities and sustain our socio-economic model and values. The rationale is that our success depends on our ability to transform excellent scientific results into innovation that has a real beneficial impact on our economy and our quality of life. Horizon Europe structure builds up on the success of H2020 structure. So we have again 3 pillars. Pillar 1, excellent science, that reinforces and extends the scientific base in Europe. Pillar 2, global challenges and European industrial competitiveness, that boosts key technology solutions for supporting the policy and sustainable development goals. And Pillar 3, innovative Europe, to stimulate market-creating solutions and that conduct to innovation. So here the difference, you see well my mouse when I move it? Hello?
Yes.
Yes, okay. Yes. So here the difference with H2020, we have 6 clusters. 6 clusters, digital, industry and space, civil, security for society, health, food, bioeconomy, natural resources, agriculture and environment, culture, creativity and inclusive societies, climate, energy and mobility. And for us, for the participants here, for us, and also has been the core of some of our activities in the last months, is cluster 4, digital, industry and space, with some areas, key areas of intervention, for example, advanced materials, circular industries, low carbon and clean industry, manufacturing technologies or emerging enabling technologies. There are other areas of intervention that are interesting also for some of the stakeholders here in Cluster 5, for example, energy system and grids, energy supply, building and industrial facilities in energy transition, or also in Cluster 6 with circular systems. So from H2020, there were some lessons learned that helped to build and strengthen the Horizon Europe. The key novelties are the European Innovation Council, R&I mission, and extended association possibilities, open science policy, new approach to partnerships, and spreading excellence. I will describe more in detail some of them. So the European Innovation Council will help to support innovations with breakthrough and disruptive nature and scale-up potential that are too risky for private investors. This is very important, and it has been identified, as I said, to bring technology solutions to market. So there will be a pathfinder for grants from early technology to pre-commercial, and an accelerator that also counts with blended finance mechanism to bring solutions to market and to ensure scale up. Another novelty are the R&I missions. R&I missions will be bold and inspirational and with a measurable goal to ensure impact for society and policy making. So far, 5 mission areas have been listed: adaptation to climate change, cancer, soil health and food, climate neutral and smart cities, and healthy oceans, seas, coastal and inland waters. The idea of the R&I missions can be compared and is often described as the mission to the moon. Well, there was in the US in the 60s, where there was a global collective strategy for research and innovation that allowed bringing a challenge, so let's say materializing a challenge that end up happening successfully. And this is the spirit of the R&I missions here. Also, open science, it was already a matter of H2020, and it will be strengthened in Horizon Europe. So open access to research data must be ensured, as well as to publications, and support will be given and reward for open science, as well as the use of European Open Science Cloud. There is also a new approach to European partnerships. The idea is to deliver on impact-focused partnerships and to avoid overlaps between partnerships and create synergies. This has been an effort that has been done since last year and over this year until the publication of the proposals of the different partnerships in June, so that we could identify the strengths and common approaches between partnerships to set synergies, as I said, and to have a strategic orientation. There are 3 types of partnerships: co-programmed, co-funded, and institutionalized. I think is yes. Next slide shows the portfolio of candidates for European partnerships, which are 49 nowadays. There are 10 in cluster 4, digital industry and space. In particularly, Processes for Planet is the successor of S.p.A, of the S.p.A partnership, as it will be a co-programmed partnership. Co-programmed means that part of the activities are carried out by the public part, which is the Commission through the programming in Horizon Europe, and a part of the activities is done by the private side and the industry stakeholders with their own activities. The proposal for the partnership was published, as I said, last June, and the approval of this partnership goes along with the approval for Horizon Europe. The partnership objectives build up on the previous S.p.A objectives, and focus on climate solutions, ensuring circularity, closing energy and feedstock loops, and also ensuring global competitiveness of European process industry. I cannot give more details so far because, as I said, these are candidate partnerships which will be approved together with the Horizon Europe soon. And these are the steps for Horizon Europe. We have been this year drafting the first work program for 2021-2022 based on the strategic plan, and we plan to have the start of Horizon Europe in the first months of 2021. This is all from my side. You can find more information on Horizon Europe and also in the Funding and Tenders portal for next opportunity. And you can also follow us on Twitter and also in the different medias of the European Commission. If you have some questions, you can address me by email, but I'm open for questions now. Thank you.
Lucia, thank you so much for your presentation, and yeah, for make this overview of the Green Deal and Horizon Europe next programs, because well, I think that it's very challenging on the objective of the Green Deal to be zero emissions in 2050. I think that it's very, very challenging. So we are going to work to perform this objective. Mm-hmm. Okay, so thank you so much, Lucia. Now we are going to continue with our event. Now it's time to present the Kyber helmet and the energy audits that we are doing remotely. So I think that now it's going to be Giorgio that is going to present.
Yes.
So Giorgio, yeah, you can share your screen and I pass you the floor.
You please tell me when you can screen.
Yeah, now it's perfect.
Thank you, Diego.
Yeah, the problem is that I listen to you very low. So
okay.
I don't know if you can speak up.
Now it's better.
Yeah.
Okay.
Yeah.
Thank you.
Perfect. Yeah. Okay. The floor is yours.
Thanks. So good morning, everybody. My name is Giorgio Bonvicini, and I am a senior energy engineer at RINA Consulting, an Italian engineering consulting company. And in the last 5-6 years, I have carried out approximately 100 energy audits at industries, buildings, tertiary sites, vessels, and so on. The focus of my presentation is on how we carry out energy audits, and after my presentation, my colleague Enrico Di Martino will present specifically how we carry out energy audits and how we use the Kyber helmet to do site visits without being physically at the site. So, what is an energy audit? Here, this slide reports the definition of energy audit taken from the European standards that provides the standard for carrying out energy audits. So, it's a systematic inspection and analysis of the energy use and consumption of a plant, building, system, or organization with the aim of identifying and reporting on energy flows and the potential for energy efficiency improvement. Okay, this is the definition. The objectives of an energy audit are to take a picture of the baseline energy consumption and flows in the industry, in the site subject of the analysis, to evaluate the consumption and calculate the key performance indicators, energy performance indicators, to compare these indicators with the best available technologies, techniques for the sector, identify opportunities for the improvement of energy efficiency, and define an energy efficiency action plan. In the next slide here, we have the energy audit process, again, as schematized in the European norm. Other European norms provide specific provisions on buildings, industries, transport, and in addition, every European member states has prepared its own guidelines for the execution of energy audits in line with the prescriptions of the Energy Efficiency Directive. The overview of this chart, except for the startup meeting, okay, preliminary activities, data collection about the plant and its production and energy consumption, analysis of the data, development of energy balances, evaluation of theoretical and actual energy performance indicators, comparison. If they are not comparable, since there is margin for improvement in terms of energy efficiency, we identify the energy efficiency actions, carry out a cost-benefit analysis, we rank the proposed opportunities, and produce an energy audit report that summarizes all the analysis carried out, the baseline situation, the proposal for improvement, technical and economical feasibility, and definition of energy efficiency action plan. So again, the main phases are, besides the preliminary contact and kickoff meeting, data collection, the site visit, that is the core of the analysis, reporting, and final meeting. So this is the core of the activity, and specifically the site visit is the core part. Let's say all the core phases of the energy audit could theoretically be carried out without going to the site. Data collection can be exchanged via email and file sharing, etc. Energy monitoring tools can be shipped to the site and installed by plant technician to measure the electricity consumption, other energy consumption, carried out checks with the thermal infrared camera, etc. The only exception was, I wrote is, but now was, the visual inspection part of the site visit, because we couldn't do before a site visit without going physically to the site, but now with this smart augmented reality solution that we have identified, the Kyber helmet, we have found a solution to complete also the site visit without being physically at the industry. Okay, I said that the first phase of an energy audit is data collection. Here, all pictures are very small, but it's just to make you see that we require a lot of data as input to the industry where we carry out an energy audit. And these data are mainly related to general data of the plant, total energy consumption by energy carrier, electricity, natural gas, other fuels, etc. Monitored consumption trends, if they are available thanks to an energy monitoring system, production values to calculate the key performance indicators, list of equipment installed at the plant with electric and thermal power, process flow diagram, site layout, etc. What we get from the industries is electricity and fuel bills, so electricity, natural gas, for example, production data by month, curves of energy, this is electricity consumption trend for a week or a month or the whole year, the layout of the site. We can receive electrical schemes, we can receive feasibility studies and offers for energy efficiency actions that they are already considering, etc. So we receive this large amount of data and documents, and we need to analyze these documents before or during the site visit. The site visit, as I said, is the core of the energy audit. During the site visit, we carried out some measurements with tools. We use power and energy logger to record the electricity consumption of different users. We use, for small loads, amperometric clamp, current clamp, infrared thermometer, and infrared camera. And we get these outputs, for example. These are electricity trends. These are images taken with the infrared camera, showing in this case, valves that are not correctly insulated and present high heat losses. We get all this kind of data, and we use this data to assess the current energy efficiency level and spot potential improvement. In addition, what we do during the site visit is a visual inspection of the plant. We discuss with the plant personnel while looking at the different departments, equipment, and areas of the plant. Of course, this could be done also remotely. While visiting the plant, we try to understand better the real layout of plants and system, to get the nominal data of installed devices, looking at the labels on the devices if this data were not available from the data collection phase, check the type of equipment, the presence of a control system, check if there is margin for improvement of management practices, and evaluate if there is area for the installation of new devices that we might recommend. All of these are carried out during the site visit together with the plant personnel, so everything is discussed with them in order to achieve the best possible understanding of the site. What we do with the Kyber helmet? We can do all what I listed in the previous slide. So we can walk through the plant to the industry with a representative of the company. We can have a visual inspection of the different areas, of the different equipment, understand the function of the different machine, the presence of control systems, how energy is typically managed in the plant, exactly as if we were there. I will show now an example, just this 1-minute video taken during the virtual site visit to TORRECID demo. Okay, as you can see, we have a very high quality of the image, and we can see everything that we want during the site visit, and also take these spot measurements with the integrated camera in the Kyber helmet. Regarding the Kyber helmet, what are the main functions and benefits? I will leave the floor after my presentation to my colleague Enrico Di Martino. Now I'm finishing my presentation on energy audit. So we have collected all the data we need. We have carried out the site visit, either physically in person or through the Kyber helmet. Then we arrive to the follow-up. So we determine the energy balances and indicators for energy consumption in the plant. We analyze the total consumption of the plant, the main activities that are production activities, auxiliary or ancillary services, general services. We determine the breakdown of electricity, natural gas consumption among the different departments and users, and thanks to the determination of these energy balances and the production data that we have collected, we calculate energy performance indicators for each area, and we compare for each area this energy performance indicator with the relevant benchmarks in order to identify where the largest margin for improvement exists. And for the areas where potential improvement exists, we carried out a feasibility study for energy efficiency measures. So we identify potential improvement. We carry out a technical feasibility study, carrying out a preliminary sizing of the devices needed, evaluation of the potential energy savings, potential avoided greenhouse gas emissions, but also we evaluate the cost, the investment cost for the realization of the measure, the economic savings, thus carrying out a preliminary financial viability check. So we produce an action plan, like in this Gantt chart, saying when we think it's better to implement the different measures. We present tables summarizing the main figures for the different actions, and then we present the results in terms of potential for reduction of electricity consumption, natural gas, water if it's in the scope of the work, primary energy, and greenhouse gas emissions. I think that's all from my side. Of course, I am available for any questions should you have, and I leave the floor to Enrico Di Martino, my colleague, for the presentation about the Kyber helmet. Thank you.
Okay, thank you, Giorgio, for your presentation. So now it's time to Enrico. Yes, you can share your screen. One.
Yes. Okay.
Yeah, now works perfect. So the floor is yours, Enrico.
Okay, thank you. Okay, my name is Enrico Di Martino. I work in RINA Consulting, and I'm the leader for the digital project team within the energy business unit. And one of our digital service is to provide the Kyber helmet technology to our client and partners. The Kyber helmet is a solution which is provided by a company called VR Media. VR Media is a company born within the University of Sant'Anna in 2002, and from that year they have developed this product that has reached a commercial availability at 2014-2016. So it's just from the last 3-4 years that we have this technology on the market. Okay, so the technology is made by an helmet, a safe helmet, which has professional headphones with surrounding volume adjustment, a frontal camera, a near-ear display, a microphone, and we have also an end-thermal camera and an endoscope camera. So this system works thanks to a specific architecture that links the remote expert with the field inspector. So we have a dedicated server provided by Kyber that connects through a local network or a 3G or 4G connection the field inspector with the remote expert. The remote expert and the field operator can share different contents in different directions. So it's possible to share audio and video, of course, up to 1 megabyte per second quality in both directions. So the field operator can see the remote expert and the remote expert can see the field operator. The number of remote expert is the maximum number at the moment is 14. So we have 3 main remote expert plus 11 people that can attend the remote inspection but cannot interact with the field operator. The remote expert can also share document with the field operator that will be able to see the document using the near-ear display. It's also possible to use an augmented reality feature that enable the remote expert to point something into the screen, so the field operator can focus the view into what has been pointed, or is possible to take a screenshot and write on the screenshot, and the field operator will see real time what the remote experts are writing into the screenshot of the view field that the field operator has. The field operator can also share, as Giorgio was sharing, a thermal camera video, or is possible also to use an optional endoscope for specific applications. So now here we can see an operator that is performing an inspection, and is using an iPad as an additional source of information, but the last model of Kyber helmet doesn't need the iPad, so we can use an additional support with a smartphone or with a tablet, but is not needed if we don't need it. Okay, so this is the remote interface. So the remote expert can see what the field inspector is seeing, can also see the other remote experts that are connected to the same session, and from this view is also possible to switch from one view to the other. So for instance, from the helmet view to the handheld camera or thermal camera view. From this session it's possible also to record the inspection session, and it's possible to take a screenshot, markup on it, and save the screenshot along with the markup that have been made. We also have a light version of the Kyber technology, which works just using a smartphone. So it's possible to perform remote site activity using the smartphone. Of course, here we have a limit on the feature that the technology can provide. So we don't have the augmented reality feature. We cannot see the document shared within the near-eye display, because here the field inspector just use its smartphone. And we also have the limit that in some plants smartphones are not allowed for safety reason, while the helmet can enter also because we have an ATEX version for the helmet. Now, it was not the case of the RETROFEED project, but sometimes we need to use an ATEX technology for a specific plant. Now, everything works thanks to the internet connection. So internet connection is a must to perform this kind of activity. The 85% of the time we are able to provide an internet connection using a smartphone hotspot, because the Kyber technology has been set in order to be utilized also with low bandwidth availability. So with the normal 3G or 4G connection, it works very well. But if we need to cover a wider area, or we need to have a very stable connection, we can use different solutions that are available on the market. So for instance, we can use a mobile router. So we can exploit the 4G connection, but we can extend the range of the local Wi-Fi that we are creating. Or we can cover wider areas building a mesh Wi-Fi network that can be built temporarily for temporary applications, or also as a permanent connection. So if we need to inspect a plant quite often, we can decide to install a mesh Wi-Fi network as a permanent installation. For very remote places such as oil rig, ships, etc., is also possible to use the satellite connection. Of course, this solution has some limits, and in the last weeks we are working to perform tests and to find the right tuning of the technology in order to work well also with satellite connection. So this technology, of course, has a lot of applications. So RINA, as a consulting, engineering, inspection and certification company, use this technology for different activities such as site visit, inspection, offshore activities, factory acceptance test, environmental survey, due diligences, PMC, and asset integrity assessment. Sorry, just 1 second. I will share. No. Okay, now I think you can see again the screen. Okay.
Yes, yes.
So now we have a quick video that shows the Kyber helmet used to perform an inspection. Okay, so we ended the presentation. Thank you for your attention.
Diego, you are mute.
Thank you. Thank you. Yeah. Thank you, Enrico and Georgia, for your presentation for this helmet and these activities that you are doing in RINA. Because, as you know, the energy audits is also very important in the retrofit project to know the current situation of the demo sites. And due to the COVID-19 pandemic, was impossible to do the site visit, and this contingency plan that you have performed, I think that it's perfect for the project, and I think that it also can be very useful for a lot of end users that can use this technology. So I hope that they find this RINA solution very interesting. So thank you for your presentation. Yes, now we are going to continue with the events. So now we are going to start with the panel discussion with the end users. So I'm going to okay, so we are going to continue with the panel discussion, this round table with then end users, but also with Enrico and Giorgio. We are going to ask some questions related with this virtual experience of the energy audits. So today the people from the end users that are going to join us is Francisca Galindo from FERTIBERIA, is the technical director of this company. Also Hassan Basri from ASAŞ, that is the energy automation manager. The company from TORRECID is going to be Juan Vicente Corts, that is senior researcher in the innovation department. From Pitini Group, Loris Bianco is going to talk with us. Is the senior supervisor of E&D projects. And from the SILCOTUB is going to talk with us Gabriel Dumitru, that is the manager of steelmaking and processes programming. But also, I think that with SILCOTUB is going to help us another colleagues. And finally, yes, I'm going to ask also Giorgio and Enrico some questions related with from Cecil. We hope we should have the participation of Ángela María Núñez today, but have a problem with another appointment and was not possible to join us. So let's start with the first question. We are going to ask a question to all the partners, and then we are going to to know their opinion. So we are going to start with the importance of the energy audits for energy efficiency in energy intensive industries. So we are going to start with Feno. So Loris.
As you, good morning. As you said, FERRIERE is an energy-intensive industry. Just to give an idea, it's like a small town, the consumption of energy in our company. Energy is used mainly to melt scrap, and after solidification is released to the environment as hot air and warm water. This means that we have a lot of possibilities to reduce input or recovery from the output through increasing efficiency or adopting new technologies. And but to do this, what is important is to know the exact situation of the energy use in detail through the process. And to do this is fundamental, in our opinion, to have an energy audit. This is what I can say.
Yeah, and in your case was I think that was a face-to-face energy audit, or was also a virtual audit?
It was face-to-face, but using for the first time the Kyber helmet. It's not the first time that we make an energy audit in our company, so it's a common experience. Yes, we have done this for many years. We started at least 10 years ago with the certification of the energy management system. So it's very, very important to have a view of the uses of the energy throughout the process and the company.
Okay, perfect, Loris. Thank you for your response. So now I'm going to pass the floor to Juan Vicente. So I think that you are there.
Hello. Sorry? Can you hear me?
Yeah, perfectly.
Yes.
Yeah.
TORRECID is an energy intensive consumption industry. We consume more than 20 million normal cubic meters per hour gas per year, and as well as 15 million kilowatt-hour electricity. Conducting an energy audit covering smelters, auxiliary equipment, compressors, dryers, and other installed equipment we have is for us of great importance to understand where our main consumption points are and how to improve the energy efficiency in these equipments. With retrofit TORRECID will improve the energy efficiency of smelters and generate waste produced. Also, collaboration with partner RINA and use of remote analysis technologies has been quite successful.
Yeah, because you were the first one of the in retrofit project that make the all energy audits in a remote way. So I don't know, it was easier or maybe it was more difficult than the other times that you make these energy audits. Do you remember more or less?
It has been quite easy. This tool is very easy to use and allow control and see and then send this information to a controller in order to optimize and to see as a real visit, as a face-to-face visit, all the facilities, the furnaces, dryers, and all the points that they are going to analyze.
Okay, perfect, Juan Vicente. Okay, so yeah, now I think that Francisca is also connected because we have some problems with the connection, but I think that now it's connected.
Yes, good morning. Everything now is solved. Sorry for the problem.
No, don't worry, don't worry.
Well, as you said, we are a high energy consumption industry because or raw material for nitrogenous fertilizer is ammonia. And ammonia raw material is, the main raw material is natural gas. So efficiency studies represent a very valuable aid to the progressive reduction of energy consumption. And in order to identify the real potentials of improvement and thus maximize the obtainable savings in energy costs, audits in energy-intensive plants are needed. They help us to detect the most consuming point of the plant and to optimize the energy use. In this moment, we are waiting for the helmet to perform this audit in our MPK plant in Huelva, but as soon as we have it, we will proceed to do the audit.
Yeah. You are going to go in the next ones that are going to test this Keeper helmet. I don't know if you know who is going to manage the helmet. I don't know if it will be there.
Someone from the plant, maybe David Fernandez or Maria Jose. One of them are very good professional, and they will do it right well. Sure.
Okay, so some of the main responsible of the plant also.
Right.
Okay.
They are working in the plant.
Okay.
For production and instrumentation.
Perfect. Thank you so much, Francisca. Yeah, and now I'm pass the floor to Hassan. So
hello, Diego.
Yeah, what told you the importance of energy audits?
Yes, okay. My name is Hassan. First of all, thank you very much, and I'm very appreciated to join this meeting. So we are sure that energy very important topics for all over the world, and also ASAŞ Aluminium and Aluminium sector is energy intensive industries and very intensive factories. So in ASAŞ we consumed more or less 160 million kilowatt-hour electricity per year and 36 million standard metric cube natural gas. This is the huge amount. So for this reason, internally we established the energy management department, and inside of energy management department, we established the energy efficiency department also. This department is my department is working as a energy audit company. So like a B plan for the unexpected cases. What we are doing with this department, we are making the energy, we are checking the energy consumption, we are checking the production values, we are making energy balancing, we are organizing the maintenance activities, energy efficiency project, and so on. So especially during the pandemic period, we saw the benefit of establishing this department. So means that most activities and most energy audits are making internally in our factories. So for some unexpected cases or for some jobs, for example, we have ISO 15001, you know that maybe this is the energy certificate. For the energy certificate, we have to make a external energy audit for each year. During the pandemic situation, even also we were held the energy audit externally. How we will hold it, like our meeting, we collect all information, we are arrange all documents, we are remotely as our meeting, we organize also energy audits very successfully. So at the end, last sentences, I can say that during the pandemic period, we performed all energy activities, all energy audits internally and externally. For the external audits, as I mentioned, that we held it with remotely without any problem, with successfully.
Okay, thank you. Because yeah, I know that here in Europe, it's mandatory to perform this energy audits. It's 40 years here in Europe, but I'm not sure if in Turkey it's also mandatory for the large industries or not. It's something that's voluntary, but maybe it's...
No, this is also mandatory.
Okay.
We have, yes, it's also mandatory, yes.
Okay. So because I have a doubt on that. So in that case, I think that it's very useful for all of you to perform this energy audit, and also it's mandatory for you. So I think that that's the question. Okay, thank you, Hassan.
Thank you, Diego.
And then we are going to continue with SILCOTUB. So I think that it's Gabriel is connected.
Yes.
Yeah. Okay. One moment. Okay, now you are on live. So yeah, what do you think about the importance of the energy audits?
Yes, hello everybody. I'm Dumitru Gabriel from Tenaris SILCOTUB. Well, for Tenaris being a large energy consuming company, around 20,000 megawatts per month, and let's say oxygen over 16 million metric cubes per year. Even if we did not have the audit within this project with the helmet in Tenaris SILCOTUB, an energy audit is performed once every 4 years, like you said before, also, which we follow being also a legal requirement for us. We had the last audit of this kind in 2019. Energy efficiency is an important issue for us because after the raw material, which in our case, steel shop, it's scrap, energy has the greatest impact on steel production cost. In addition to the financial side, reducing the impact on the environment is an important factor that concerns us all.
Okay, thank you, Gabriel. So you performed an energy audit last year. So it was only 1 year before the last one. But do you think that you will have different results from the energy audit that you performed in the last year, or will be more or less the same?
Well, since last year,
yes.
Well, since last year we start to improve some topics, but even consider this, I think we can improve more, and I hope to find different ideas, different solutions to our problems and to our energy efficiency.
Okay, thank you. So, yeah, I don't know if finally, Giorgio, Enrico, do you want to add something for the importance that you think that are the energy audits for the companies?
Yes, I'd like to start by saying that generally energy-intensive industries have a very high and very good knowledge of the energy flows within their site, their industries, so they are probably those that benefit less of an energy audit compared to small and medium-sized industries. However, although energy-intensive industries have typically carried out mandatory energy audits, have an energy manager, and are continuously analyzing their level of energy efficiency, it's useful also for them to have an external professional coming and carrying out an energy audit because she can provide an external view of on their industry, also based on what he has seen in other plants, in other sectors. So also in the retrofeed project, it's useful to have this energy audit in all the industries, in all the demo sites, to have a common methodology and have consistent results and to calculate the impact also of the retrofit project at the end of the activities.
Okay. Okay, thank you, Giorgio, for your response. I don't know if Enrico, you want to add something? Or you have more or less the same? Okay, okay, perfect. Okay, so thank you. Now we are going to make another question. So Anna, if you want, you can continue.
Yes, in this discussion, we are interested in the retrofitting solution because so many different activities have carried out in a different end user. So the question is, what difficult have you identified for implement the retrofitting solutions? I mean, in the data gathering, digital actions, mechanical actions, data exchange. There are so many subtasks that we have to do. So, which is your impression about the implementation with difficulties or barriers have you identified during this time? So we can start for TORRECID for Juan B. Courts.
Hello again. For us, energy audit carried out will provide reference values and KPI to compare with the future situation once the retrofit measures have been implemented. In addition, we expect to implement the experience, the know-how, all the results and improvements in the furnace monitoring and energy savings installed in the project furnace and extend these improvements to the remaining furnaces.
Okay, so that is very. So you see a replication, a further replication of the solution of the retrofit project.
Of course.
Yes. That is very good to hear. So thank you very much, Juan B. What about ASAŞ, Hassan? What do you think about this term?
Of course. Hello, Anna, again. So in our side, I think there will be no any problem because of them. We have many experiences about new investment and implementation. So what we are doing that we collect all the information regarding to needed during the implementation, and after that we should finish the all layout detail with our subcontractors, and also we should arrange the installation detail. We arrange the manpower, especially in our factory, in internal manpower. We should organize. We organize the time planning, and after that, with this information, we collect this information. We start implementation. In my mind, there will be no any problem because of them. As I mentioned, that we have many experiences in ASAŞ. For each year, we are making new investment. We are adapting new machine, new lines, new project, and so on. But maybe it will be a small problem about the system technique side because of them. You know that for the retrofit project, the system technique will produce the curing furnace, sent to the transfer to the ASAŞ. We will start the implementation or installation. During this time, maybe we lost a little bit time, and after that, we will cover it, I think, without any problem, in my opinion.
Okay, that's perfect. It's just to see that ASAŞ is a very innovative end user, so you are used to deal with very challenging solution and actions. So that's great, Hassan.
We hope so that there will be no problem. We will finalize it successfully. We hope so.
Perfect. Thank you very much, Hassan.
Thank you. Thank you.
And what do you think? In this case, FERRIERE or Loris from Pitini, what do you think? what do you see the implementations and the retrofit solutions?
Yes, the retrofit solution in our case is try to substitute fossil coal or methane or natural gas with biomass and or with plastics. This means that we have two problems to implement this. One is the feeding, what is and it is related to with something which is outside our company, and so we have to find a way to feed this material. And the other is to use this material in our process, which is a very complex, very speedy process. And so we have to be at the same level of efficiency in all the aspects of use of these materials from the from the point of view of energy, performance of the process, and so on. This is our work, what we see to do to implement reflex idea,
yes,
retrofit idea in our process.
And of course, to maintain the quality standards of your product.
Yes, sure. This is a prerequisite.
Exactly, that's mandatory. So,
yes, sure.
Exactly. Okay, thank you very much, Loris. What about Gabriel from SILCOTUB? Gabriel? Is Gabriel?
Yes.
Okay, sorry. Gabriel, what do you think about that you have the device and difficulties in the data gathering or data change, mechanical actions, digital actions? So you know, we have so many activities to implement in the retrofit. So what do you think? How you identify some barriers or difficulties?
Yes,
yes.
We face some difficulties at the beginning until we start to manage our meetings, our discussion more online. Considering the problem with the visits in this context, in this actual context, but considering all this, we start to work and to learn more how to organize, how to online meetings, how to transmit data. Okay, there were many mails, of course, and discussions. Okay, besides this, let's say we were facing some small problems now regarding feedstock characteristic and the different injector that we need to use considering different feedstock. Okay, but we are working on this, and we consider that will not be a problem to finish on time all this all what we already established, let's say. Of course, regarding the audits, energy audits, we are following our last audit and from 2019, but also the discussion of this regarding this project, and we are waiting also for the helmet. Regarding the audit from 2019, the actions are mainly based on the efficiency on the fluid producers such as compressed air, water pumps, air dryers, but also on electrical substation, shutting down transformers and streamlined the electrical energy during idle periods practically. Anyway, following the retrofit energy audit, we expect to find opportunities for improvement that we want to apply.
Okay, that's good. It's very good. Okay, thank you very much, Gabriel, for your contribution. And Francisca, what do you think about what are we discussing? What do you think about the difficulties that if you have identified some difficulties?
Well, after the audit, of course, we didn't do it. Well, once we have a deep knowledge of the energy consumption of our plant, for example, red points, energy losses, etc., some action can be carried out implementing an energy management system. Not only investing in reducing energy consumption, investing in equipment, for example, reducing losses by isolating equipment or lines, optimizing controls are very important, etc. But also ensuring the maintenance over time of the efficiency level reached once the improvements have been implemented. That's very important. And regarding the retrofit project, we are going to start a novel reactor. This is based on ammonia and sulfuric acid, very different from the one which is based only in sulfuric acid and ammonia. And having in mind that the reaction, the exhaustivity of the reaction of ammonia and sulfuric acid is much more higher than the reaction of sulfuric acid and ammonia, we are sure that the energy consumption will change for better, of course. So this is what we expect from the implementation of the new retrofitting reactor in our plant.
Yeah, in your work package, yeah, is the pilot plant and
right.
it's very innovative reactor, and yes, it's very challenging. Your proposal, so your demonstration will be very interesting also. So thank you very much for this discussion. To all of you, it was very interesting. So Diego, we can go through the third question.
Yes, well, I think that taking into account that we are a bit out of time, I think that it's better to carry on with the events. I think that now I'm going to pass the floor to Bernd, that is the project coordinator of the REVAMP project, that are going to present us the project and explain the objectives and the main results, because I think that maybe the last question that is related with COVID-19 will be explained at the end of the project, at the end of the event, or so on. So Bernd, the floor is yours, so you can share your screen if you want.
Yes, I would like so. Let me check. So can you see it?
Yes, one moment. Perfect. I send it to yeah, now it's perfect.
Okay, thank you very much. So first of all, thank you to the consortium and the coordinator of the RETROFEED project for inviting me to give a short overview on the, let's say, sister project in the same S.p.A call, which is called REVAMP. So the full title of this project is Retrofitting Equipment for Efficient Use of Variable Feedstock in Metal Making Processes. Our project is focusing, as the title says, on metal making processes. So it's not so broad in the different, let's say, sectors of the process industry as your project. But nevertheless, I think we also have some similar aspects as in the RETROFEED project to be handled in our REVAMP project. So my name is Bernd Klein. I'm a department manager in the VDH Betriebsforschungsinstitut in Düsseldorf, Germany. And our research institute is mainly dealing with steel making processes. So I will first give you a very short overview on the REVAMP project, on objectives, methods, on the demonstration cases and expected results. So what are the main challenges for our project? The main challenges are to cope with the variable material feedstock. So the feedstock is mainly scrap material coming from post-consumer industry, and so this feedstock has very variable properties, and so we have to handle these variability. Then secondly, we have to use various and also alternative energy sources to optimize the energetic performance of the processes. And we finally, of course, all the plants for metal making industry should operate with maximum efficiency. So the objectives of our project are, first of all, a characterization of the raw materials of the material feedstock. Then we want to optimize the charge mix for the different processes in terms of cost, but also in terms of quality and energy consumption. So we have a part in the project which deals with preheating of the scrap by alternative fuels before the scrap is then filled into the furnace for melting. We will deal with the optimization of the energy mix of the different melting furnaces, and we will also optimize the furnace operation as a whole. And we will perform some offline simulation and optimization calculations, but the main purpose will be to enhance the online process control of the different processes. So the methods which we are using are a very strong part of our project is dealing with the development and application of new sensors, especially for material characterization, but also for furnace operation. New equipment will be mainly focused on the scrap preheating device. Then we will develop enhanced process models, which then shall be used for multi-criteria optimization, decision support systems, and also process monitoring and control. So we have 3 demonstration cases inside the project. The first one is the steel making process in different kinds of furnaces. Then we have the aluminium production and the lead production. All 3 processes are using recycled material, which is mainly scrap coming from different sources. So, and the expected results of our project are quite similar than for your project, of course. So we want to improve the resource efficiency and the energy efficiency of the processes. We want to increase the productivity, improve the quality, and to let's say to ensure a constant quality of the final products. And overall, of course, we want to reduce the CO2 emissions of this energy-intensive processes. So to come into some more detail regarding our project objectives. So we want to develop, adapt, and apply novel retrofitting technologies to cope with the increasing feedstock variability, and also to ensure an efficient use of this feedstock in terms of materials and energy. And this shall be done by development and application of novel sensors for characterization of metal scrap regarding its chemical composition. Then we will develop a metal scrap preheating system, which will be operated with waste-derived fuel. That means we will use waste from plastic waste, mainly coming from the automotive industry, so-called shredder scrap or shredder plastics, which shall be used as fuel for this preheating system. Then we will develop and apply several software tools to model the operational input conditions of the processes and use then these models for monitoring and control to optimize the processes for the metal production at varying feedstocks. So we have demonstration cases with 3 different use cases from the metal making industry. So for steel making, we have 2 industrial partners. One is using an electric steelmaking plant, and the other one, the classical steelmaking process route with a blast furnace and an oxygen steelmaking furnace. Then we have two plants with which are performing aluminum refining, also from aluminum scrap, and then one plant which is performing leach recycling, mainly from used batteries. So the retrofitting solutions which we will develop will be also evaluated in terms of economic and ecological effects, as well as we will take into view cross-sectoral applicability in other process industries. And finally, of course, we will valorize, disseminate, and exploit the project results for the process industry. So to come into some more detail regarding the different methods and technical approaches which we will follow in the project. So we will first of all analyze the material and energy feedstock for the different metal making processes. Then we have a large part dealing with the scrap preheating equipment for preheating of aluminum scrap. And also a main focus of the project will be to develop several sensors for feedstock characterization. So there will be some, let's say, more general sensors like gas temperature and composition sensors, especially for the scrap preheating equipment. But the most of the sensors will be used for characterizing the metal scrap in terms of its composition. So here we will follow the development of a so-called neutron sensor, which is using in the end gamma rays to analyze the composition of the metal scrap. This will be a sensor which is able to analyze the bulk of the scrap material, because all sensors which are available so far can only analyze the surface, but cannot look through the surface, for example, of a scrap pile or of a scrap load in a truck which comes into the plant. So with this neutron sensor, we want to analyze the bulk composition of the scrap material. And in addition, we will use a more or less conventional LIB system, laser-induced breakdown spectroscopy, which will be able to analyze the surface composition of the steel scrap. Yes, and then we will have a large part dealing with development of models. Material flow analysis models will be one part, then an analytical process models, statistical and artificial intelligence-based models, and energy efficiency models. And these will be used then for process control and decision support, which covers a charge mix optimization for the processes to define the optimal mix of the different feedstock materials for an efficient metal production. Then we will have monitoring and prediction of the process behavior inside an online control system. And this will also cover some model predictive control approaches. Yes, the demonstration cases are shown here once again. I mentioned them already. And then we will have also some tools for evaluation of the results, which will be mainly several KPIs and also a life cycle analysis for the three production processes. Project consortium and its distribution to the different methodologies. So the REVAMP consortium consists of 16 partners from 3 different European countries, Germany, Spain, and Poland. So we have 7 research institutes which are working in the field of sensor development and development of process models and tools for process monitoring, control, and optimization. Then we have 4 companies for providing the sensor technology and the plant equipment. 3 of them are SMEs. I will come back to the different companies in the next slide. And then we have 5 world-leading industrial companies from the metal production sector, 2 steel plants, one in Germany, one in Spain, and 2 aluminum production plants, both in Spain, and then we have a lead production plant also in Spain. And at these industrial companies, the different retrofitting solutions will be implemented and demonstrated in their application for improvement of resource and energy efficiency in an industrial environment. So this map shows how the partners of the project are distributed along the European countries. So we have a very strong fraction in Spain. Here we have located the 2 aluminum production factories. One is FERRIERE, which is working together with a plant supplier for the preheating equipment, and also with the research institute Astalan in the north of Spain, the Basque Country. Then we have a second group in Spain with Exide for lead recycling and lead production, working together with Cardiff, a research institute. And the third party in Spain is the company Grupo Lart, also for aluminum refining, and Eurecat as the accompanying research institute. And then we have also a steelmaking plant, Sidenor in Spain, also in the Basque Country. On the other side, we have one further steelmaking plant in Germany, which is belonging to a very large group of steelmakers, the ArcelorMittal group, which is the largest steel producer in the world. And they will participate with their plant in Bremen, north of Germany. Yes, and then we have 2 groups developing the sensors. First of all, the lip sensor, which will be developed by a Fraunhofer Institute in Germany, and a SME also in Germany. And then we have a group in Poland, which will develop the neutron sensor. This is consisting of the National Center for Nuclear Research in Poland, and 2 SMEs which will develop the equipment for this neutron sensor. Yes, and then of course we have a coordinator of the project, which is BFI, our institute, and we are mainly dealing with the steelmaking processes and also have all the coordination functions in the project. And then we have a university, RWTH, Aachen University. They will mainly perform the life cycle analysis and the material flow analysis in the project. Okay, so our work plan looks like this. We have 4 work packages which will provide all the equipment and the tools which shall be then applied in the different use cases. So we will have a work package dealing with the analysis of the variable feedstock. Then we will develop the process modelings, the sensors, and the dynamic monitoring and control systems. We will then apply them in the second half of the project in the 3 different use cases. And then, of course, we have some overarching work packages like project management, dissemination, exploitation, and also a work package in the second half of the project, which will deal with the evaluation of the retrofitting solutions. Now, some words finally regarding our experience in the COVID-19 crisis times. So the kickoff meeting of our project, which started, by the way, on the 1st of January this year, 2020. So this kickoff meeting was the only face-to-face meeting which we could have so far in the project. So all further project management meetings had to be held as web-based meetings. So we used Microsoft Teams for that. These meetings, however, worked quite well when considering the spread of partners in the project from west to east across Europe. So, of course, the main drawback for the scientific and technical project work was that almost no plant visits were possible. So there were some plant visits inside one country, but especially for the research institutes and SMEs who develop the sensors for characterization of the metal scrap. So they would of course need to visit the plants where their equipment, their sensors shall be implemented. And this was so far not possible to have a physical plant visit. So the group in Poland will develop the neutron sensor. The group in Germany will develop the LIPS sensor. And both sensors shall be installed at the industrial sites of the metal production plants, which is the steelmaking plant in Bremen, the aluminum refining plant in Spain, and also the lead production plant in Spain. So we try to overcome this problematic situation by some kind of virtual plant visits, which have already been arranged or will be arranged in the future. And in this context, I was very happy to see your solution, which you are following with the Kyber helmet for a virtual plant visit. So this would be a very good tool also for our purposes, probably not with the full functions, so I don't think that we would need an infrared camera or something like that. But to have a camera on a helmet where the process engineer can go through his plant and visualize the situations where sensors can be implemented for the sensor developers, this would be a very good tool for us also. So what we did so far was to use simply Google Earth photos, for example, here for the open scrapyard of the steelmaking plant of ArcelorMittal Bremen. So with this tool, we could at least also already localize where the best positions for installing the sensor equipment to analyze the incoming scrap, which is coming into the steel plant by trucks, could be monitored and analyzed. And also we received some photographs which are taken from every truck entering the plant, where we can see how the scrap load looks like. And you see here a very bad example of steel scrap, where you can get a good impression how inhomogeneous and how variable the scrap feedstock for a steelmaking plant can look like. So you see here an example of a very low quality scrap type with a very wide mixture of different scrap pieces, and it will be very difficult to analyze this kind of scrap pieces in the bulk analysis, but also in the surface analysis. So nevertheless, of course, the partners of the consortium hope that plant visits and also face-to-face project meetings will be possible again in spring next year, which will for sure allow a much more effective project work for us. And I think this hope is shared by everybody who is performing research projects at the moment, because I think we all suffer from this situation that face-to-face meetings are not possible at the moment. Yes, this was already the last slide of my presentation. Thank you very much for your attention, and of course I can answer questions if there are any. So for further information, you can also visit our project website, revamp-project.eu. And of course, you can also contact me directly via email or phone. Thank you very much.
Okay, Bernd, thank you so much for your presentation and for your time. Yeah, I think that you have a lot of things that are very related with our project, related with the analysis of the stock, the sensor adaptation, also the monitor and control system that you are going to develop. So I think that we have to be in contact to know all the updates of both projects. And also, yeah, also we are happy to know that you have made also some COVID-19 contingency plan that you have implemented during the project, because I think that it's also very very important to know that all the projects are looking for solution for this problem. So thank you for your presentation. And yes, hopefully we think that in the next year we are going to have a lot, again, face-to-face meetings.
Yes.
Maybe this presentation of these meetings will be more useful.
Yeah, so maybe we can also organize, if possible, a face-to-face meeting among the consortia of our two projects. So as far as I understood, these are the only two projects in this S.p.A call. So maybe it would be a good opportunity to get to know each other in a let's say small conference where the project partners can show their first results and can share them with the partners of the other project.
Yeah, for sure, because as you know, you are the mosaics are close related with three of our the mosaics. We think that it's very important to keep in touch.
Yes.
So thank you so much, Ben, for your time. And well, we are out of time. I think that we can finish the meeting here. I know that we have some questions and some comments that will be interesting to answer, but I think that it's enough. It is 2 hours of the dissemination event. So thank you for all the presenters, from Francisca, Hassan, Juan Vicente, Loris, Gabriel, Giorgio, Enrico, Ber, and Lucia for joining this meeting and help us in this dissemination event, because you are the most important things, the most important people in the project. So thank you so much. And also I want to thank EIP for preparing this event to help us in preparation of the event. And well, this meeting has been recorded, so it's going to send to all of you to check all the information, and also to consult in our website and also in our social media channels. So thank you to all to attend to this meeting, and of course, if you have any doubt or any question of the project, you can check our website. You can also write in Google RETROFEED and you will take it to our website. And also, well, if you have any doubt or any question, you can send Anna or me this question. We'll have to answer. So thank you so much for your time, and see you next time. Bye-bye.
Thank you, Diego. Thank you all presenters. Thank you.
Bye.
Bye-bye.
Goodbye.
Thank you.
Bye-bye. Thank you.
Thank you, Anna. Bye-bye.